In this video, we'll take a look at some of the key performance considerations, more about some of the performance metrics, then setting up the collection levels and summarization. We'll also talk about performance charts, which gives us a pretty good view within the vSphere client of specific things trended over time as a graph. But ESXTOP is a command line tool we can use in the shell, which provides us a pretty graphically dense view of a lot of different performance data all at once, so it could also be quite interesting. We'll talk about key performance indicators for both hosts and virtual machines. So in terms of the vCenter performance metrics, once you have vCenter, you're able to do performance reporting on historical data. The vSphere desktop client has various charts and things, but it'll only show you real-time data when you're using a host without vCenter. So once you have vCenter configured, what you're going to want to do is specify what level of detail you want to collect. By default, it'll collect level 1, and you can go as high as level 4, but really level 2 or 3 is probably where you want to be. Level 2 adds a lot more detail about the individual virtual machines. That could generate more data, but I think is pretty reasonable and the kind of information we would probably want to know. So what we also need to specify is the summarization level, so how long we want to keep non-real-time data. So we can keep data, for example, at level 2 or 3 for 5 minutes or a day or a week or something, but we wouldn't necessarily want to keep it for all of that long. Although what really contributes to database growth is actually not the amount of data you keep for a year or a month, it's the data you keep for 5 minutes. For level 3, VMware's recommendation is that you don't keep that more than a week. And for level 4, they recommend that you don't leave it running that way at all. Do what you need to do and then set it back down to level 3 or level 2. So depending on how many hosts, depending on how many virtual machines, depending on how long you keep all this data, that's going to add up to system overhead, which shouldn't be too bad except in level 4, and database growth. When you go into the settings in vCenter, though, it's going to give you an estimator for what your database size will be. Make sure you plan for that. Within the vSphere client, we have various performance charts that we can access. In the vSphere client connected to a host, then we can only see the hosts and virtual machines. When we're connected to vCenter, we can not only get the historical data, but we can also look at clusters and data centers and these objects that exist in vCenter that don't exist on standalone hosts. So at the data center level, we can get some pretty high-level details of the storage and CPU and memory for all of the clusters and all of the hosts in our environment, but you don't get any real-time statistics. You just get the historical data. For data stores and data store clusters, we can get the storage and I/O details. And then for hosts and virtual machines, or things that are effectively collections of hosts and virtual machines like clusters and resource pools, we can get the full detail about CPU, memory, disk, and network utilization. And the performance charts are useful, but now what you may want to do is look at ESXTOP, which runs in the shell, that basically gives us a lot of different views of the system activity, and you can run it in batch mode, which you shouldn't really need to do, but if you're running the free version of ESXi and you don't have vCenter, you can actually use ESXTOP in batch mode as part of like a cron job on the host to actually export this data on a regular basis. But what you may need to do is change what's displayed. So what you can do is you can change the displayed column with the F shortcut keys and change the displayed order with the O keys. And then effectively we can switch between the different views. And you can switch from the CPU view with the C key to CPU power with the P shortcut, or the interrupt view to see what's going on with our device drivers with the I shortcut. And you've also got memory views and disk and virtual machine disk views, as well as the network views. So there's a lot of detail in here. I mean, really is the same things that you'll see through the performance charts in the vSphere client anyway. But for more detail on both these, I would definitely recommend that you read up on the vSphere performance data in general, but specifically on ESXTOP. There's a good community document on the communities.vmware.com site, doc 9279, and the link is here in the slide. So some things to watch for, depending on whether you're using ESXTOP or whether you're doing it in the charts, you'll see this slightly differently. But anyway, physical CPU usage is definitely important, but there's a little bit more detail that we need to be aware of with that, and we really want to look at what our virtual machines are doing to try and understand what is actually happening and what's not. I/O device latency could definitely add up, so looking at the device average commands per second, I believe is what this counter is, and that'll give us some idea as to whether or not we're experiencing I/O latency, and we may need to start looking at changes to our storage. Probably also knowing about the dropped percentage of transmitted and received packets, and the physical memory free is important to know, but also taking a look at the VM kernel memory state is also a very good idea. So what will happen is, depending on how aggressively VMware is under memory pressure, it will start acting differently. Once VMware hits about 6% of free memory, then that's going to start going into a memory pressure mode, or at least once it gets below 6%. In the initial state, when it's starting to have pressure but not too much, then we have basically what we call soft mode, where the system is trying to use the balloon driver to influence the virtual machines to give up memory to the other virtual machines that need them. At a certain point, we reach the limits and we have to go into, effectively hard mode and start swapping the virtual machines outside of their own swap. So the ESXi kernel is going to have to do this itself. And it's never going to do it as well as the virtual machine would. It doesn't really know anything about what memory is being used more often or less often and so on. And it's going to do things just less effectively. We might want to plan for that. We could certainly add local swap. We can do various things to speed up swap performance, doing things like putting swap on SSD, using things like the flash cache in the system. There's lots of things that we could do potentially. So again, taking a look at this VM kernel memory state is really going to give us a good idea. Although again, really the physical memory is going to tell us that you're running low on memory. But once you start hitting that 2% or so level, then you may see that your I/O starts increasing a lot because of swap. It's not an I/O problem, it's really a memory problem, right? So it's important that you're actually able to correlate all these things and try to understand how a certain condition in one area can lead to side effects in another area. Like I was saying, if you start swapping and the system starts compressing memory, we're going to see higher CPU usage. It's not really a CPU related problem though, and it's not really an I/O related problem. As for the virtual machine key performance indicators, the percent system time tells us how long VM kernel is having to spend trying to honor requests on behalf of this virtual machine. So if this is getting really high, you may have a virtual machine that's generating very, very high I/O, or maybe you've got a driver problem with that device or whatever that it's using. Percent wait time is useful to see, generally speaking, how long we're waiting, but it doesn't tell us whether we're waiting for CPU or whether we're waiting for I/O. From a CPU perspective, if you look at percent runtime, you'll be able to get a better idea of how much CPU time you actually got. But if you look at percent ready time, you'll get a better idea of how much time you actually spent waiting for CPU time. And percent ready is useful, but it could be misleading. So for example, if I've set virtual machine CPU limits, then effectively once that virtual machine reaches its limit, all of its requests have to be dropped. So that will actually show up under ready time, but is actually a factor of the CPU limiting. So if you see ready time is high and the MLMTD is also high, max limited, something along those lines, then that would tell us potentially that we've got a virtual machine with limits set, and then we'd want to review why we're doing that or whether that's appropriate or whatever. The other thing that could occur is what's called co-stop. Co-stop is where we've got multiple virtual processors with a virtual machine, and they're getting somewhat out of sync. So if one virtual CPU is doing a lot of work and the other virtual CPU is not, or even on a larger scale, some CPUs are doing a lot of work and some are not, then basically VM kernel has to start doing work to keep them in sync because of symmetric multiprocessing. So it has to force them somewhat to get into sync again. And so what it will actually do is start issuing stop operations against that CPU just to kind of keep them running at the same pace. So if you're seeing that and you're seeing that this is elevated, then potentially we've got virtual CPUs that the virtual machine is not needing, or at least it's not needing them right now. Maybe it's going to need them again in the future. So we'll take a look at the demo and we'll take a look at some of these performance charts that we can do. We'll dig into some of the different areas, mostly just to show you some of the capability here and point out basically what you're going to be experiencing, but you really should be reviewing the VMware performance guides. We'll also take a look at ESXTOP, again, mostly just to familiarize you with it, but again, I would definitely recommend you take a look at that Interpreting ESXTOP Statistics document. So I'm in the vSphere web client, and we're going to configure performance collection. So a question of how much detail do we want to collect, and then how long do we want to keep data at those different levels. So I'm going to click on to vCenter inventory lists, and then in the list of resources, I'll click into vCenter servers. And this is somewhat buried, but is basically where we need to go to configure a lot of the vCenter configuration options. So then in the list of vCenter servers, I'll just click my vc6.vlab.local, and then you can see over in the main area, I've got an edit button that I can go in and edit the vCenter server settings. And under statistics, you see I have this option for how we want to collect statistics, which really should specifically point out that this is performance-related data. So if I change the statistics level for the 5-minute interval duration, and let's say for the 30-minute interval duration, I'll set it to a different level and so on, then we can get additional detail and keep it for as long as we feel is necessary. Now, that having been said, depending on the number of hosts and virtual machines that I'm using, that's going to generate potentially a lot of data. So you can see in that model would have been 88.4 gigs of data. If I change that down to, 2 hosts and 1 virtual machine, you can see it's like 600 megs of data, so really not too bad. And you might think it's the data that you keep for a year that's a problem, but it's really the data that you keep for like 5 minutes to 30 minutes to the 2-hour period that's going to be a bit more of a problem as well. And so you can see that boosting up level 4 at other levels really doesn't increase the size of the database all that much. It's the data that I keep for 5 minutes that's really going to be significant, because everything else is really just a consolidated roll-up of that 5-minute data anyway. So it's not really adding to the database, it's taking data out of the database. So anyway, choose the appropriate combination of statistics that you want. You really should not leave the system running at level 4, and collecting level 4 data this way is going to generate quite a lot of overhead in the system. And in this case, you can see not really that much space in the database. So once we've configured the collection of performance data at the level that we need it to, we can go in and start taking advantage of all that. So right now I'm in the vSphere web client, I'm looking at a virtual machine, and I'm going to click onto its monitor tab. In there, you'll see we have a sub-tab for performance, and we've got various charts available to us here. So under the overview, you can see that it gives me some details. Let's try and make this fit a little bit better. You can see that it gives me some details of CPU and memory. I can view that view or the storage view, and then I can choose the time period that I'm interested in. Now, that having been said, some of these time ranges, if I haven't let enough time pass, it may not have actually added any data points to it. So that, like I was saying before, could take anywhere between 5 minutes to a day to actually update some of those levels. So you can see that I've got details about my CPU usage, my memory usage, in swap in, swap out rate, as opposed to like pure memory utilization percentages, although we have that here as well. You can also see my disk read and write rate, the disk requests, the virtual disk rate that we can see in terms of the read and write rate, as well as the disk requests and the network requests that we're getting. So it gives us a pretty good view of what's going on overall with this particular virtual machine. And if you scroll down, it says, well, you're running on ESXi 6-2, so you may want to go and click here in order to get a view of the host rather than the virtual machine. We'll take a look at the host later on. But if I click into Advanced, then I get a lot more options to choose exactly the details that are interesting to me. So you can see by default here, it's showing me my CPU utilization overall, as well as in variations of that. I've got a few different views I can use here. I can change into the data store or the disk or the memory or the network or the power view for these virtual machines as well. And it gives me a pretty good set of information. Now you have to be careful once you start graphing more than a couple of things together here, exactly what these axes actually represent. And sometimes the left-hand side and the right-hand side will be on different scales or representing different values and so on. So if you're looking at things that don't necessarily correlate directly to each other, definitely a good idea to be aware of that. So again, we have all these various different views. If one of these, works for you and gives you exactly the information that you're interested in, great. Beyond that, what we may need to do is go in and customize these and define our own. So you'll see that I can go in and export these charts in, different graphics formats, or even in a comma delimited format that I could bring over into Excel. So I guess if I wanted to make it look different, I could bring it into Excel and make it look however I want. But if I go into the chart options, then we have the ability to define exactly what we're interested in for these different views. And you can see there's a lot more information that we can add here if it does interest us. And you'll see that basically all the things that we were talking about in the performance around things like ready and co-stop and system time and use time is all in there in whatever category you're interested in. So there's a lot of information here. I mean, it could be a little intimidating. Trying to look at it on an individual virtual machine level might not be great, but I will tell you that using the performance monitoring tools in the virtual machine is not always the best approach, because a lot of times it's going to give you inaccurate data, or at least it's not going to give you a good context around why things are happening. Memory utilization that the virtual machine reports, that is really because of the ballooning driver is really not useful to tell us it's using a lot of memory. So if we customize this the way that we like, then we can go ahead and we can save that as a new chart. And then we'll see that that actually just appears in the list of charts under the advanced view. And then I can just go back to it quite easily if I need to. So now that I've got my screen rearranged a little bit and I've got my navigator back the way where I expect it to be, you can see if I go to the cluster level, for example, I can get similar sorts of reports, although you can see that we can break out the resource pools and virtual machines across the hosts, as opposed to just the hosts themselves and their utilization. So this is a good way to do it. Like I said, trying to look at things at the virtual machine level for a single virtual machine, it's going to be pretty hard to get the big picture. And so again, we can also go and take a look at it for hosts across the entire cluster. And based on these stacked graphs, you can actually see that although ESXi62 actually seems to be a little bit bigger, it's really just kind of a more dominant color because it's stacked on the bottom. But because the ESXi61 has much higher values, then it's utilizing a lot more. So we need to be a little bit careful with how we interpret these graphs as well. So yes, and if we go under the advanced, you can see that there's a whole bunch of other alternative views here for the hosts as well. But just like we did for the virtual machines, we can go customize those as we need. ESXTOP is a very powerful performance monitoring tool. Maybe not as user-friendly as the graphical chart features that we have otherwise, but still pretty good. So I'm SSH'd into one of my hosts and I've just launched ESXTOP. One thing you should definitely take note of quickly is the CPU load average listed in the top right-hand corner. If that is 1.0, or getting close to 1.0, then that indicates full system load. Beyond that, you'll see we also have things like physical CPU used and utilization. I'm not sure the exact distinction between the two, but you can see that my system load right now is really quite low. But as we go down the list, we can see all the different system processes and how much CPU time they're using and getting, and so on. So if we want to go through some of that, I would definitely recommend looking at that interpreting ESXTOP statistics document that I mentioned before. But you can see that we have things like % used, % run, % sys, % wait, % ready, and % limited, % co-stop, and so on. So one thing you might want to do here is actually switch it over to view just the virtual machines. I don't actually have any virtual machines running on this host right now, but if I use, I believe it's uppercase V, I can switch over into the virtual machine view. So if we switch over to some of the other views with like the M key, you can see for all the different processes, their memory stats. You can see up at the top, we have things like how much physical memory we have available, and also how much VM kernel memory we have available. And if you look through over to the, I guess, sort of in the top right corner here, we can say we've got the state as well. So if you are seeing low physical memory, then we may potentially be into a situation where we start getting into, the hard swap mode and so on. So this would give us some indication that that's all happening. You can also switch over the storage views with, I believe it's D. So in here, you may want to take a look at, again, the device average latency. So that column D average CMD is generally going to tell us when one of these adapter paths has a problem. Now, if you're into a situation where you have multiple adapters and you're supposed to be using multipathing, then ideally that would be relatively well balanced, but there's no guarantees for sure. And take a look more at the storage videos for details on how to make sure multipathing is working, how things like your path selection policies have been set, and whether or not they're actually working the way you want them to. So if I switch back over to the CPU view, we also have the option to modify the displayed fields. So if I use the F key, I can go in and you can see that there's potentially other detail that I can add in there as well. So in this case, I guess I'll add the CPU summary stats and the power stats with, I guess it's I and J here that I need to use. Now, I've added so much that I can't really see them, so what I may also want to go in and do is change the display order with the O shortcut. So once I do that, I can use the different columns and I can move them around a little bit. So you can see potentially up at the top where I was doing current field order, as I was changing them and hitting J a bunch of times, that was moving it up in the list. And so now when I go back out of that view, then you can see now my power column is listed at the beginning rather than at the end off the edge of the screen. Now ESXTOP is pretty useful, but there's also other versions of this, so you may want to take a look at some of those as well, like vimtop, which can be integrated into the HTML5 client. But there is a little bit of help here, so if you bring up the help with H or question mark, you see there's a little bit of detail on how to change the fields, how to change the order, how to set up updating, and so on. So in summary, you really are going to want to set vCenter's collection level probably to level 2 and retain that data for at least a week if you want to troubleshoot or monitor any real virtual machine usage. You might want to set it to level 3. Probably you don't want to set it to level 4. Be very careful with reservations and limits. There's a lot of weird tricks that the system needs to do to make those reservations and limits happen. So if you're monitoring very high memory usage for a virtual machine and it's something you reserved, or you're seeing very high ready time for a virtual machine, but it's because it has to dump a lot of CPU cycles, then potentially we're not doing things in a way that's going to make it easy to monitor the system. Resource pools make that better, although a similar kind of problem just grouped across multiple virtual machines or maybe even across multiple hosts. So that could be a bit difficult to deal with too. Don't over-declare resources. Don't give virtual machines much more memory than they really need, and definitely don't allocate them any more virtual CPUs than they really need. And sure, we can create a virtual machine with 128 virtual CPUs, but is that really absolutely necessary? And is it maybe not better to distribute that workload across multiple virtual machines and use some kind of load balancer or something? I wouldn't necessarily go as far as saying to always create virtual machines with only a single virtual CPU. I prefer to do 2. But then again, they might need far more than that. Intel-type systems use symmetric multiprocessing, so all of our CPUs have to be co-scheduled, and that means that it's not available for doing other work. So when it's sitting there running in co-stop mode, another virtual machine is not able to use that CPU. If you allocate a lot of CPUs, then it can definitely mess with the multitasking and the opportunities for scheduling virtual machines that do need it. And definitely make sure that you've got your environment tuned well for performance. So having, up-to-date firmware, having up-to-date drivers installed, having the right configurations, tuning the queue depths, using the various offload features that your hardware supports is all going to help a lot in getting good performance out of your environment. In the next video, we're going to take a look at alarms so that we can get notifications when some of these performance conditions and things are starting to occur.